science.
Okay, so what about stuff like this? Now, after 5.1, which dealt with the graphs, we started talking about everything we've done since then has really been centered around solving quadratic equations. Okay, and we've only got we're going to have more soon. You know, beginning of second semester, we'll have a bunch more techniques, but for now, we only have two. We only have two ways that we can solve quadratic equations. One of them is we're going to have to use to solve this guy. So what do we do here? What do you think? Yes, ma'am.
Subtract x squared on the right side
Yeah, that's right.
to the left side.
Okay. Good. We're going to want to subtract. In fact, we want to push everything to one side here, don't we? Okay. Which side do we want to push all the terms to? To the left side. And the reason being, because we want to have a positive number of x squareds. And that's 2x squared is more than 1x squared, so we're going to gather them on the side where we'll have a positive number of x squares. In other words, the leading coefficient needs to be positive. So if I do that, if I subtract everything on the right to the left, what do I get? 2x squared minus x squared is?
X
squared.
Yeah, I don't even have an x there, but if I subtract the other x over there, I get that, right? And then negative 3 minus 3, negative 6. Good. And that's equal to 0. Okay? You're going to kick your ass. Okay, so the reason we do that is because now we've written this as a quadratic equation in standard form, where everything is set equal to 0. And the reason we go about doing that is so we can use the zero product property. We don't have the luxury here, do we, of isolating x? How come?
Because there's two.
Yeah, I can't point to a single x, so I can't isolate it, right? I'm stuck having to do something else. And the something else that we talked about was factoring and then applying the zero product property. So we got to try to break this thing up break it apart into unbreakably small pieces. And then the product of those pieces has to equal 0, right? Now, if I factor the left side, I always want to try to factor out a greatest common factor if possible. But can I do that here? No, there is no number I can factor out, and one of these terms doesn't even have an x to give away, so I can't factor out any variables, right? So we're stuck without a greatest common factor, but hopefully I can break this apart. Now, what's it going to look like if I can break it apart? If this does factor, what's the template going to look like? Okay, I'm going to get my factors, right? And I know, what about those I'm hearing? Okay, my first term in each factor is going to be an x, isn't it? So I get an x and an x, and now I just have to find out if there are magic numbers that do the job for me. I need to find numbers that multiply to negative 6 and add to negative 1. Okay, so what are those numbers?
Negative 3 and positive 2.
Negative 3, positive 2. Are those my solutions?
No.
No, good, they're not. Those are the magic numbers. Now, if the question, and you got to read these carefully, you got to really get in the habit of reading the directions on the problems because they ask different things. The problems look very similar sometimes in chapter 5, but they ask different things. Now, if this problem says write in factored form, that's it, isn't it? Right? We would just literally write that down. Okay. Okay, but the other thing it could say is it might say find the zeros of the equation or solve the equation. And it's going to say separate your answers with a comma. Okay, but so it might be, and like this one did not ask us to write it in factored form. It asked us to solve. So now what do I do to finish the job here?
You have to make them into zeros, so
Good.
it has to be positive 0.
Good, good. Now the only way,
3.
right, now that's exactly right. The only way that I can get a product of factors to equal 0, only way I can get 0 for an answer is when I multiply by 0, right? So either x minus 3 has to be 0, or x plus 2 has to have a value of 0, right? What's the x value that would make the first factor, x minus 3, 0? X equals 3 would be one of my solutions. Okay, what's the other one? Good, so in Moodle I would just do something like that. Okay? All right, good. Okay, this is a little harder, right? Got to go through one of these. Now these, I'm not going to load you up with these. I did give you, I think, 3 or 4 of these to do on the assignment. And that's as many as you're really going to have to do. I'm gonna give you probably one of these on the review, and I will give you one of these on the test, but that's it, okay? These are the ones where, and the reason I'm doing that, and you'll see why soon, because we're gonna have some other easier methods for solving equations that look like this, other than factoring. Okay. But for now, that's all we have. And factoring is an important skill in math, just, it's like being able to use proper grammar when you're writing. I mean, it's one of those things that just that process itself is useful later on in math classes. So that's why I'm making you do it. This is one where I just want you to factor it. It doesn't say solve, it just says factor it. I want to break it apart into pieces. What's the problem here? What's different about this one?
X isn't 1.
Yeah, A is not equal to 1. A is equal to 18. So what do we always want to try first that hopefully could make things easier? What do we want to do first? Say it again. What are we going to do first? Factor out what?
The X.
The X. Oh, okay. No, you lost track a little bit here. That's up here. Okay, suggestion. What do we want to try to do? It may not be successful. Greatest common factor. Okay, is there one? Is there a number that divides into 18, 9, and 14? No, there is not. Can I undistribute an X?
Yeah.
Where's the X?
No.
I can't. This one doesn't have an X to give away, right?
Yeah.
So we're stuck. I can't factor out a greatest common factor. If I can, it always helps. It makes the numbers smaller, much easier to work with, but I'm stuck. So I have to do the A times C then split B thing, don't I? Right? So what's A? 18. What's B? What's C? Negative 14, good. Okay, so now how does that saying go? A times C, then split B, right? That's what we have to do. So we have to find the product of A times C, right? Which is just negative 252. I have to find numbers that multiply to AC, that multiply to negative 252, and add to B, right? So this is my goal. I got to find numbers that multiply to this, and they add to that. Okay, so let's get as much information about these numbers as we can. What do we know about their signs?
One's gonna be one's gonna be
Opposite signs, good, because they have to multiply to a negative, okay? So which one is bigger?
B.
Of the two numbers, positive and a negative, which one's bigger?
Positive.
The positive, because they add to a positive, right? How much bigger is the positive one? 9. Because when you add up the negative and the positive, there's 9 positive left over, right?
Yes.
Okay, so that helps. There's a couple strategies we can do for this. I'm not going to give you a lot of really big ones like this to deal with. Now, we could just try to find factors of negative 252 that add to 9, but that's kind of hard to do because negative 252 is a big number. We could probably do that, but that's a lot of work. Instead, we could also look at it this way. We know that we have to have a positive number that's 9 bigger than the negative number, right? So we could also just try pairs of numbers that fit that pattern and just see if we can find some that multiply to negative 252. That's probably easier, right? Like we could start, for example, let's start with, here's going to be our positive side, and there's our negative side, and there's going to be, and here'll be the product. Okay, so here's the product of the two, okay? So positive, we could try something like 18 and negative 9, right? Because 18 is 9, but you see what I'm saying, those add to 9? And that's not going to be big enough, is it? That's only going to give us, what, 162, negative 162? So I need bigger numbers. Okay, so I could try, what if I tried like 21 and negative 12? That does it, right? That multiplies, those multiply to negative 252. So those are my numbers, right? I'm going to split the B equals 9. I'm going to split that 9x for the B. That's going to split up into, like negative 12x plus 21x. I'm going to split the 9 into those two numbers. That splits that middle term, okay? So now we can go back to the problem and we can do that. Our magic numbers, remember, are positive 21, negative 12, right? So if we go back over here, that's how I'm gonna choose to split this up. I mean, I don't get to choose, that's how I split it up. Those are the numbers that worked. Yes, ma'am? Yes, you may. So we end up now, instead of 18x squared plus 9x, we're gonna get 18x squared minus 12x plus 21x. Still just 9x, but split into two terms. Minus 14. And I could go in either order. I could put the positive 21x there and the negative 12x there too. It doesn't make any difference. My personal preference is if one's negative and one's positive, I always like to put the negative one first. It just seems like it's a little bit easier. I mean, it's a tiny bit easier to me, but I don't think it's that big a difference. Okay, now do you remember how that pattern works, what we try to do with this? We broke it from 3 terms into 4, so we could do what? So we could, okay, true. So we could group two groups of 2 instead of one group of 3, right? So we're just gonna do this. First 2 get grouped together and the second 2 get grouped together. And then we're just gonna follow this pattern, right? The pattern was, we're gonna focus on the first group and we wanna factor out the greatest common factor from the first group, which is going to give me a leftover factor from the first group. And what did we immediately do with that leftover factor from the first group? Do you remember? We used it for the second group. Good. Whatever the leftover was from the first group, we immediately used for the leftover of the second group. So look at the progression. Greatest common factoring out the greatest common factor of the first group left us with a leftover in the first group, which becomes the leftover of the second group. And then the very last thing we have to do is we just ask ourselves, okay, what has to be distributed to that leftover to make group 2? It's that way every time. Okay, now we'll fill in the blanks. What is the greatest common factor of the first group? What's the number part? 6. Everybody agree? 6 is the biggest number that goes into 18 and 12. Okay, how many x's can I undistribute? X to the 1. So I can undistribute a 6x. What am I left with? Okay, well, what's 18x squared divided by 6x? 3x, right? So that's what the first term is going to be. Whoops. What's negative 12x divided by 6x? Negative 2. So what goes over here? Same thing. 3x minus 2. Now, what would I have to distribute to the leftover 3x minus 2 to get that? 7, right? Does that make sense? 7, no, we're not quite ready. 7 times 3x is 21x. 7 times negative 2 is negative 14. Okay, and now we got one more step and we've got it factored. Right? Look what we got here. And this is where sometimes people just kind of let up and say, oh, we're done. We're not one step away. One step. All I have to do now, I've got group 1 and group 2. I've got a common factor in each group, the leftover factor. Remember, that was the same in both. So I'm going to undistribute that from each group, or factor it out. If I undistribute the 3x minus 2, what's left?
6x minus 7.
Okay, what's left if I do that? If I undistribute the 3x minus 2, what's left in the first group? 6x. Good, right? If I undistribute the 3x minus 2, group 1 leaves me with 6x. Group 2 leaves me with plus 7, right? Factored.
And is that how we put it in the main?
Yeah, it's a lot.
Is that how we put it in?
Yes, that's how you put it in. Okay, hold up. Okay. So if this is asking you to write it in factored form, that's it. Now, it doesn't matter which order you put those factors in, but those are the two factors that it breaks apart into. If it's asking you, what if it said instead, solve the equation? Well, we would have had this set equal to 0, right? So how would I find my zeros, the solutions? Okay, yeah, I'm just gonna set these equal to 0 and solve, right? So I would have the equation 3x minus 2 equals 0. So I'd add 2 and divide by 3, right? And get x equals 2/3. Or over here, I get the equation 6x plus 7 equals 0. So I subtract 7 and divide by 6 and get negative 7/6.
Is that how we put it in the?
Well, it depends. Now, if they're asking for the solutions, I would enter those numbers. If they're asking for factored form, I just write it like that. Okay? All right, last issue, pretty easy one. Oh, yeah, sorry, not quite. Okay. Okay, the good news is, that is the hardest thing that you do in chapter 5, is A times C then split B. In fact, it's one of the hardest things we probably do all year. Okay, here's the other kind of thing, though, that you're going to see on the test. Now, this is different and much easier. Okay, why is this so much easier? We're just solving this. Is all we're doing.
Oh, don't we have to do it?
Well, not really. But there's something important here. Rather than thinking of it as a form, I want you to think of it as there's a certain look here that tells us what strategy to use. Okay, say it again.
You gotta solve for.
Okay, we're going to solve, but what's...
Is it reverse PEMDAS?
Okay, yeah. So what am I doing? Hey, listen. Quit talking. What am I doing?
Reverse PEMDAS.
Okay, in order to do what? What am I? You're right. You're exactly right. What am I trying to do to that x?
Isolate it.
Isolate it. Okay, how come I can isolate x here and I couldn't in the first one?
There was no x's.
Because there's a single x. Exactly. If I can point to a single x, I can always isolate it by reversing PEMDAS, reversing order of operations, right? So here's a single x. All I got to do is get it by itself. Now, listen carefully to this. Is where people make the mistake. This is much easier. Don't undo the work that makes this easy. Sometimes people have a tendency to want to do things like distribute the 2, which you can't do anyway, because this is being squared. Or maybe they want to FOIL this out and then distribute the 2. No, that's making things much harder. If I do all that stuff, I'm going to end up with a big A times C then split B problem that's going to be horrible, right? We don't want that. We want to do the easy stuff, which is isolate the x. When we talk about isolating a variable in algebra, that's really a very descriptive way to think of it. Because we literally are trying to just move everything over to this side of the equation, to the right side, except the x. We want to leave the x isolated by itself on the left. So we're just going to pick apart the left side piece by piece, step by step. And the order in which we pick it apart is dictated by reverse PEMDAS, right? So what's the first thing we're going to do then? Subtract. Yeah. So we're going in that direction. So the first thing is subtract 7. Good. We got to add or subtract. Okay, so if I subtract 7 from both sides, I'm left with 2 times the quantity 3x minus 1 squared equals what? 44. Okay, now what's next in line?
So times
Divide by
no, divide by 2.
Divide by 2, good. Multiply or divide. And here's where people make the mistake. They say multiply or divide. Okay, let's multiply by 2. No, we don't want to multiply the 2. The 2 is being multiplied. So to undo multiplying by 2, we divide by 2. Our goal is to get rid of that 2 from this side and incorporate it into this side, right? So we will divide both sides by 2, because dividing by 2 undoes multiplying by 2. Agreed?
Yes.
Okay? And so now we're left with, at this point, okay, good question. Okay, the question is, when I divide by 2, how come it doesn't change the 3x minus 1 squared? Let's look at an example with numbers. Okay, what if I had 12 divided by 2? Okay, isn't that the same thing as 12 is the same thing as 3 times 4, isn't it? So that's the same as 4 times 3 over 2, right? Agreed? Well, is that the same thing? 12 is just 4 times 3? This answer's got to be 6, doesn't it?
Yes.
Because I know that 12 over 2 is equal to 6, right? Okay, so then my question to you is, Do I have to divide both the 4 and the 3 by the 2 on the bottom? No. I only am going to divide once. I'm going to divide because I've got 3 factors here. 4 times 3 divided by 2. So I can do this in many different ways. I could divide 4 by 2 and get 2 and multiply by 3. I could multiply the 4 times the 3 and then divide by 2. Or I could divide 3 by 2, which would be inconvenient, and multiply by 4. But I'm not going to double divide there, am I? Right? It's the same thing up here. If I divide both the 3x minus 1 by the 2 and the 2 by the 2, I'm actually dividing by 4. Right? So I'm just going to pick the easiest of those possibilities. I'm going to divide first and get rid of those. Right? Because look what I'm doing. I'm taking 2 times this factor divided by 2. Of all the different ways I could do that, isn't the easiest one to first divide and cancel them out? 2 divided by 2 is 1 times that is itself. Right? Another way to think about that in the language of Algebra 1 is we're just canceling common factors. I can cancel something from the top and the bottom of a fraction if the somethings are both being multiplied. The 2 is being multiplied by the 3x minus 1 squared, so I can cancel it. Now, it'd be different if I had instead, I want you to see this, if I had instead something like this. What if I had 2 plus 3x minus 1 squared divided by 2? I could not cancel there because the 2 is not being multiplied this time. See the difference? It's not a factor, it's a term. I can only cancel like factors. I can only cancel a 2 on the bottom with a 2 that's being multiplied by everything on the top. Okay? That make sense? Right? Okay, so real quick, I'm not sure that I'm not convinced that makes sense there, but so I want you to reduce this for me.
Busy. Yeah.
What's that equal to?
Who knows? I'm just
Y over z. Yeah, do you see why? Okay, the x's cancel this time because the x's are being multiplied on the top and the bottom, right? Okay, so that equals y over z. What about this? I can't do anything there. There's nothing I can do to reduce that because nothing cancels there, right? I got one more. Compare that to this. Yeah, this time the x's do cancel because the x on the top is a factor and the x on the bottom is a factor. Okay? See how that works? All right, so back to our problem. How does that relate to our problem? Okay, so then if I divide by 2, I'm left with 3x minus 1 squared equals what, 22? Okay? So what are the things we've done? We subtracted, then we divided by 2. Now what's next? Exponents. What does that mean in this case? What do you mean by exponents? Square root, right? I have to undo the squared to get the x by itself. To undo a squared, I would square root both sides. Okay, so if I square root both sides, the squared and the square root cancel, but here is where people tend to make a mistake. Okay, that gives me 3x minus 1, but what do I have to introduce if I square root both sides of an equation? What always shows up?
Positive or negative.
Plus or minus. Exactly. Okay, I gotta get a plus or minus the square root of the right side, which is just the square root of 22, which I can't reduce. I can't simplify. Okay, so I've actually got 2 answers there instead of 1. Now there's 2 possibilities. Okay, now last 2 steps. Add 1 first. So we're going to go 3x equals, and remember what we do. If I have a plus or minus, I always put the number in front of the plus or minus. So I get 1 plus or minus the square root of 22 in last step.
Divided by negative 3 plus 3.
Good, I divide, well, no, I divide by 3, the whole thing.
Oh,
And if I divide the whole thing by 3, look what we get. I get 2 answers, right? So when I enter these in Moodle, there's literally 2 different solutions there. One is the plus sign, one is the minus sign, right? So I get x equals, and you fill in the blank. It's either 1 plus the square root of 22 all over 3, or 1 minus the square root of 22 all over 3. We don't put the x equals there, we just put the numbers in, right? Either order, doesn't matter which order you put those in, but I put a comma in between. Make sense?
Yeah.
Okay. All right, so so now the heavy stuff's out of the way, last minor issue, simplifying radicals. Very, very quick, not a big deal. What do I I think everyone knows how to do this pretty well, but just make sure we're all on the same page. I just put up an assignment on this stuff. How do we simplify the square root of 150? What's our goal? Yes, ma'am.
Find the perfect square.
Okay, I want to find the biggest perfect square factor of 150, right? And what I would do if I were you, when you're doing this kind of stuff on a test, I would just make a list on a piece of scratch paper of all the perfect squares, so you have it available. 2 squared is?
4.
Okay, next one. 9.
16, 25, 49, 64, 81, 120.
Okay, we can stop there. Okay, so then here's how we can do this. We want to find the biggest perfect square factor. So we always start with the number. Is 150 a perfect square? No. Okay, if the number itself is not a perfect square, then the next biggest possible candidate would be half of the number. So half of 150 is 75. Is that a perfect square? Nope. So then I only have to look at perfect squares less than 75. So it's just those, and we can cross them out as we go. Does 64 go into 150? No. 49? Nope. 36? Nope. 25? Yes. So 25 is the winner. Okay, so I would write this as, split it up into the square root of 25 times the square root of what? 6. Good. And what's the square root of 25? 5. Good. 5 times the square root of 6 is it. Okay? And if you're given a product of radicals, like the square root of 10 times the square root of 30, what do you do? Neither one of those is a perfect square by itself. Multiply them together. Yeah, I'm going to get the square root of 300 and just do what we just did. So what is the biggest perfect square factor of 300?
103.
100 times 3, yeah. So my answer is just 10 times the square root of 3, isn't it? Right? Square root of 100 times square root of 3. Okay? All right, what about dividing? Okay, last issue. Last example and we're done. Okay, if I'm dividing square roots, what's the first thing I always do? Well, actually, there's 2 things I want to look for right away. Okay, good. I want to see if I can reduce the fraction under the radical. So 17/50ths, unfortunately, doesn't reduce. But what if it did? If I had something like 10/50ths, I could make that 1/5, right? And make things a lot easier. Okay, so I want to see if I can reduce the fraction. This time I can't. So once I've reduced it, in this case I can't reduce it, then what do I do to that fraction? Separate the radicals. I'm going to separate it into a square root of the top divided by a square root of the bottom. So we'll write it as the square root of 17 by itself divided by the square root of 50 by itself. And now I'm just going to try to make each of those as simple as possible on their own. So what about 17? Is there a perfect square factor of 17? No, 17 is prime, isn't it? The only factors of 17 are 1 and 17. So no hope there. The top we're stuck with. Bottom, pretty easy. We just did one like this kind of. What's the bottom breakdown into? 25 and 2. Okay, so that's going to give me I'll go down here. Square root of 17 over 5 times square root of 2, right? Square root of 25 breaks down to just a 5. So what's wrong with that? There's one little piece here that's I got to deal with.
There's square roots on the
Can't have square roots on the bottom. Okay, remember what our strategy is. See if we can remember. If I get a stranded square root on the bottom, what do I always do to the top and bottom?
multiply it by square root.
Yeah, good. I just multiply both the top and the bottom by the stranded square root. So in this case, that's the square root of 2. And the reason I do that, on the bottom I've now got 5 times the square root of 2 times the square root of 2. I can multiply those three things in any order. Why not multiply the square roots together first? What is the square root of 2 times the square root of 2, which is just the square root of 2 squared, right? It's the square root of 4, right, which is 2. Okay, they just completely out. Okay, and here's how you can always think about that. If I multiply a square root by itself, think what we just did. The square root of 2 times the square root of 2 is just the square root of 2 squared. Isn't that what it means to multiply something by itself, is to square it? So the squared and the square root cancel, just leaving me with whatever's under the radical as a number, right? As an integer. So I'm left with a 5 times a 2 on the bottom. What's that? Okay, on the top, so that worked. I got the radical out of the bottom. What am I stuck with on the top now? Square root of 17 times square root of 2 is the square root of, and I got to at least try here to simplify that, can I? Nope, there's no perfect square factor of 34. 4 doesn't go into it, 9 doesn't go into it, no 16, no 25, obviously no 36, so we're done, right? That's okay. I can have a radical on the top, I just can't have one on the bottom. So that's my answer. Good, we made it.